At Trinity, we recognize that many people deal with tank cars each day. Some of you move the cars from one place to another. At either end of this journey, people are involved in loading or unloading product from tank cars. And no matter where a tank car is, there are support people, such as fleet managers, car coordinators, and traffic personnel making sure your car is where it needs to be and in working order. Some of you are involved in maintenance and repair of these cars, similar to Trinity's Railcar Repair Division. Another group of people at Trinity are devoted to designing the finest tank cars on the rails today. Trinity's highly trained and experienced engineering staff uses state-of-the-art equipment to develop the designs and drawings used to build our tank cars. To do any of these jobs, we must first have certain basic knowledge of tank cars and their components, as well as knowing our way around the car. This presentation will not make you an expert on tank cars, but will give you a general understanding of tank cars and their components. To begin, let's look at how to identify a tank car. Each tank car is stenciled with a car classification, which tells us many things about the car. For additional information, you can refer to the Code of Federal Regulations, as well as the Association of American Railroads Manual of Standards and Recommended Practices. To help you understand the car classification, we'll break it into 6 segments, explaining the basic meaning of each. The first segment represents the governing body. Here you see DOT, which indicates the U.S. Department of Transportation. If it reads TC, it stands for Transport Canada. AAR stands for Association of American Railroads. The second segment of the car classification refers to the car type. This will answer many questions about the car. Is it a non-pressure or pressure design? Does it have a dome or a manway? Are the bottom outlets prohibited? And so on. The third segment is normally called a separator. It is also used to indicate special features, such as thermal and head protection for certain non-pressure and pressure tank cars. Segment 4 tells us the tank test pressure. These pressures range from 60 to 600 pounds per square inch. The tank construction is indicated by the 5th segment of the car classification. In this case, W means welded. And finally, the 6th segment indicates special features such as fittings, insulation, tank material, and linings. Remember, for additional information explaining car classification, refer to the DOT's Code of Federal Regulations and the AAR's Manual of Standards and Recommended Practices. Now that we know what type of tank car we're looking at, let's learn how to find our way around it. The car is divided into 2 distinct areas from end to end. They are designated as the A end and the B end. You can tell the B end from the A end by looking for the handbrake. The handbrake is always on the B end of the car. The car is also divided into right and left. As viewed from the B end of the car, your right is the right side of the car, and your left is the left side of the car. However, when viewing the car from the A end, remember that your right is the left side of the car, and your left is the right side of the car. To locate components such as wheels, axles, bearings, and other parts, we use a numbering system. This system starts at the B end with the first axle assembly and progresses to the A end with axle assemblies 2, 3, and 4. Now that we can identify a tank car when we see one and determine the A end from the B end, let's learn a little about its components. We'll start with the tank, which is the part of the car that holds the commodity or product. It consists of 2 heads and the shell. These components can be configured differently depending on the car class and the commodity being transported. The basic configurations you will see are the straight shell tank, the straight top sloping bottom tank, and the sloping top sloping bottom tank. Other significant differences in the tank design that are of interest to us are the material the tank is constructed of, as well as the tank diameter, capacity, and thickness. Many commodities transported by rail must be heated for unloading when they reach their final destination. This is accomplished by the use of heater coils, the most common being the exterior serpentine system. Coils of this type are generally constructed of half-oval sections welded directly to the tank shell. They typically use steam or hot oil to heat the tank, which in turn heats the commodity. Because of improved underframe and tank reinforcement designs used by Trinity Industries, we are able to offer the LT coil system. This system provides a feature found in no other new cars today: full-length heating of the tank bottom centerline. Another common heating system is the interior serpentine coil. This type of system is normally constructed of 2-inch pipe supported just above the inside bottom of the tank. With this system, heat is transferred directly from the coil to the commodity. To minimize the amount of heating required, or maybe eliminate it altogether, we often insulate the tank car. The most common insulating materials used are fiberglass and urethane foam. They will range in thickness from about 4 to 8 inches. In addition to insulating materials, you may find thermal protection materials. These materials protect the tank where fire conditions may exist. No matter what material is used, we are required to protect that material from the environment and/or other abuses by covering it with an 11-gauge steel jacket. We've talked a lot about the tank and its components. Now let us talk about the systems used to move the tank car from point A to point B. These systems start with the underframe. We have two basic designs of underframes: the stub sill and the continuous center sill. The underframe most commonly used today is the stub sill. In the stub design, there are two assemblies, one at each end of the car. They consist of two major components: the bolsters and the draft sills. This design is an integral part of the tank and is preferred because of its light weight and strength as compared with the continuous center sill. In the continuous center sill design, the tank rests on two cradles, one at either end of the underframe. It is held in place by an anchor attached to the center sill and 4 turnbuckles, one at each corner, attached to the bolsters. In this design, the center sill extends from one end of the car to the other. Continuous center sills were commonly used on older cars. Today, they are primarily used for special car types. These underframes are mounted to the truck assemblies. The trucks, in turn, allow the tank car to be moved along and guided by the rails. A truck assembly consists of the following basic components: the side frames and bolster, which form the framework for all other truck components; the springs and snubbers, which absorb movement between the side frames and bolster; the wheel and axle assembly, including the roller bearings, which allow the tank car to move and guide that movement along the rails; the bearing adapters, which provide a mount for the roller bearings to the side frames; the center pin that guides the center plate into the center bowl of the truck bolster. Side bearings provide support against rocking the car body while in motion. And finally, the brake components, which will be discussed later. It should be noted that these are the most common components of a truck assembly. Some designs may be more complex. The underframe also provides a location for the installation of draft components. These components will provide the means to couple one car to another, as well as absorb the loads. The components are the draft gear, which acts as a shock absorber when the car is pushed or pulled; the coupler, which is the actual connection device to the other cars; the yoke, which holds the draft gear and coupler in place; the follower block, which transfers loads from the coupler to the draft gear; and the coupler key, which holds the coupler in the draft sill. We have learned about the systems that move a tank car. Now let's talk about the systems that are used to stop a tank car. Slowing down or stopping a tank car is accomplished by equipping each car with a pneumatic mechanical brake system. There are two types of brake systems commonly used on tank cars: body-mounted brakes and truck-mounted brakes. The differences between these two systems are in the mechanical portions. The pneumatic portions of both systems are very similar. Common components of the pneumatic portion are the train line, air brake hoses, control valve, reservoir, and brake cylinder or cylinders. The mechanical portion consists of one or more cylinders, a push rod or rods, levers, brake beams, brake shoes, and one or two slack adjusters. There are times when we'll need to apply the brakes to one or more cars when they are not in transit. This is done by means of a handbrake, which acts like a parking brake on your auto. To operate the handbrake, we simply turn the hand wheel. This in turn will operate the brake system. Now that we've learned about the components that stop the car, let's look at the devices used to load and unload tank cars. First, let us cover a few general items which pertain to many of the fittings arrangements that we'll talk about. Making sure that gaskets and seals are in good condition is of the utmost importance. A damaged seal, or one that's incompatible with the commodity, may allow the commodity to leak during transit. Another important item is the tightening sequence and torquing of fasteners. Improper torquing of the fasteners or tightening them in the wrong sequence could prevent the gasket or seal from doing its job. Incompatibility of mating stainless steel components can be another problem. When certain materials are used for threaded connections, a condition known as galling may occur. This condition causes the materials to diffuse together in a way that prevents them from being separated. And finally, all valves and fittings, as well as their arrangement, must be AAR approved. Now that we've looked at some of the basics, we will look at bottom outlet valves. Although there are many different valves used for bottom outlets, the most common are the ball valve, wafer sphere valve, bottom-operated plug valve, and the top-operated bottom outlet valve. Always remember, before operating any valve, check for leakage and attach the appropriate lines. Use your company's loading and unloading procedures as a guide. The first valve we'll examine is the external ball valve. To operate the valve, remove the locking pin and move the handle downward 90 degrees. Another type of bottom outlet valve is the butterfly or wafer sphere valve. It also provides a very small profile. Most components are the same as on the ball valve arrangements, except for the valve itself. To operate the valve, first depress the locking device on the handle. Then rotate the handle downward 90 degrees. The next valve we'll discuss is the bottom-operated plug valve. This valve appears similar, but unlike the previous valves, the nozzle extension is an integral part of the valve. It houses the operating mechanism, where a standard cap and plug are used. To open the valve, rotate the handle 180 degrees and pin it so it will remain in the open position. The final bottom outlet valve that we'll discuss is the top-operated bottom outlet. On the bottom of the car, we have a standard outlet extension cap and plug, but the operating mechanism is on the top of the car. To operate this valve, go to the stuffing box cover located on the top of the car on the stuffing box nozzle. Invert the cover over the top of the operating rod. Turn the handles of the cover counterclockwise to open the valve at the bottom of the car. We will now look at some of the common fittings found on top of the tank car, beginning with safety relief devices. There are several types of relief devices, all designed to relieve pressure. Some use positive pressure and some use negative pressure. One type of safety device is the safety valve. There are two different styles, the internal springed valve and the external springed valve. Safety valves are used to relieve positive internal pressure. Their pressure setting is based on the tank test pressure. As the pressure in the car rises to something higher than the start to discharge pressure, the valve opens and releases pressure to the atmosphere. As the pressure decreases inside the car, the valve closes. The next type of safety relief device is the safety vent. A safety vent is a one-use device. As the pressure in the car rises, a disc ruptures, allowing the pressure inside the tank to escape. This device will then remain open to the atmosphere until a new disc is placed in the vent assembly. To inspect a ruptured disc, simply remove the pin and open the cover. Our final safety relief device is designed to relieve a negative internal pressure. It's called a vacuum relief valve. As the pressure in the tank decreases, the valve opens. It should be noted that safety relief devices can be dangerous when they're operating, so stay clear of the discharge opening. We will now turn our attention to the manways. There are two basic styles: the hinged and bolted manway, primarily used for access, and the flanged and bolted manway, used for access and the mounting of various fittings arrangements. The nuts on all but the safety bolts are loosened, and the eye bolts are removed from the cover. The nuts on the safety eye bolts are then loosened